Now second one is sin raised to nx minus cos raised to nx. Now the rule first we will use, that is a minus b, differentiation of a minus b. Then we will use second one, that is x raised to n. Then we will use sin x. Then we will use cos x. As we know the rule of differentiation of a minus b, that is differentiation of a minus b becomes differentiation of a, that is sin nx, minus differentiation of b, that is cos raised to nx. Now I'm going to differentiate this first term and second term separately so that you can understand clearly. Now differentiation of sin raised to nx is as this type of example I have already solved in lecture number 1, so you can attend that, so you have clearly you can clearly understand this this differentiation. Now let differentiation let sin x equal to y, so y raised to n becomes differentiation of y raised to n is n y raised to n minus 1. Now replacing this becomes n sin n minus 1 multiplication, that is differentiation of sin x, that is cos x. Now consider this as 1. Now we will differentiate the second term, that is differentiation of cos raised to n x, that is let cos x is equal to y, that is y raised to n, that is n into y raised to n minus 1. Placing this becomes n into cos raised to n minus 1 x. Then differentiating this cos x becomes minus sin x, that minus here sin x. Consider this as 2. Now we will put the values in main question. As I solve, differentiation of sin x becomes n sin raised to n minus 1 x into cos x minus n cos raised to n minus 1 x into sin x, that becomes plus, as sin differentiation of cos x minus sin x, then minus becomes plus. This minus term I'm including as total, I'm not doing this separately. Now that becomes, now further can be simplified as taking common of n sin n minus 1 cos x plus cos raised to n minus 1 sin x.